He's seen. All right. So here we go. On this one here, all right, everything that we have given to us right here, we have the vertex given to us, which is -2, +1. So therefore, I can get the axis of symmetry to be -2, and I can notice that the x-intercepts are going to be non-existent because they don't cross. So no x-intercepts. We got that. We have to write the equation. The equation is going to come from the vertex and 0, 5. I could pick any point I wanted on there. I could pick anything over here just as long as where it crosses between on the grid. All right, and so I'm going to plug it into this. This is my vertex form. My vertex is going to go in as h and k, and my x and my y is going to come from the other point at which it passes through. So this is going to be 5 equals a parentheses 0 plus 2 squared plus 1 down to one variable a. And so now I'm going to solve for a using my order of operations. I'm going to take care of parentheses, which is going to take care of my 0 plus 2, which is 2. Now it comes 2 squared plus 1. I'm going to take care of my exponents, which is going to make it a times 4 plus 1. My multiplication and division is going to take this a times that 4 and make it 4a plus 1. I can't combine any of those because nothing's with like terms on this side because one has a variable, one doesn't. So now I'm going to solve using my adding and subtracting. Okay, and therefore I'm going to get 4 equals 4a. My multiplication and division, divide by 4 to create a 1. I have 1 equals a. All right? So since I now have my value for a, I'm going to go up here and plug it in and write my equation in standard form. All right, so if I was asked, and I think you were asked in your test, to write one equation in vertex form, so you just plug those things in, and you'll leave your x and your y. Why do x and y stay in equations?
Input and output.
Input and output, domain and range. Very good. So that's going to be my 1 parentheses x plus 2 squared plus 1. All right? And so that would be my vertex form of the equation. My standard form is going to come from condensing it down. So it's going to be y equals, I'm going to take care of my parentheses. There's nothing I can do inside the parentheses, so I'm going to go to exponents, which is going to have me breaking this apart into 2x plus 2's. X squared plus 2x plus 2x plus 4, and then a plus 1 on the outside. Remember, you can't distribute this one through. That one will come through after I get done. So I combine my like terms. That's what I have. X is going to, or y is going to equal distributing my 1 through everything. It's not going to change. Okay? I'm going to have x squared plus 4x plus 5 is my equation. Now, what do we know about the x-intercepts again? There is none, okay? Can we find the imaginary x-intercepts? I didn't require you to do so. You could write no x-intercepts, that's fine, but you were probably requested or will be requested further on test to find the x-intercepts even if they are imaginary. And so we can do that. We can do that. So, in doing so, let's find those x-intercepts for ourselves. I'm going to plug it into the discriminant, which is d equals b squared minus 4ac. And what I'm going to get is I'm going to get b squared, which is 4 squared, minus 4 times a, which is 1, times c That's going to be 16. Let me know if I run off the end down there. Minus 20, which is going to be negative 4. Okay? Negative 4. So here's what you should know from this point. We're still going to use the quadratic formula to find our x-intercepts here in just a second, but what you need to know is that 4 is a perfect square, correct? And so my imaginary x-intercepts are going to come out to be factorable. Okay, they're going to come out to be factorable, but we'll finish using the quadratic formula to solve them because we use b squared minus 4ac up here, so we've already taken care of that. All right, and so my quadratic formula is going to be negative b plus or minus the square root of d, which is b squared minus 4ac all over 2a, and the difference between this one is you won't be able to put it in your calculator to do so because it has an I and it won't be a real answer. So my negative b is going to be negative 4 plus or minus the square root of negative 4 all over 2a, which is 2. Okay? Now, how does this simplify? What do I need to factor out of it first? The negative 1, right? I need to break it apart to that right there. That's the same thing. These two radicands multiply together, they give you negative 4. And so that takes care of my I, and what's the square root of 4? 2. And so what I have left is I have negative 4 plus or minus 2i all over 2. Okay? What's the common factor between all of those numbers in the triangle? 2, 2, and 2. So I have negative 2 plus or minus I all over 1. So those are the imaginary roots as well. Okay?